Example 8, John has a part-time job at the local grocery store. He's been asked to create a display of cereal boxes. The top 6 rows of his display are shown below here. So keep in mind, this would actually continue further. They're just showing the top 6 of his display. The number of boxes in the rows produces an arithmetic sequence. There are 16 boxes in the 3rd row from the bottom. So because we don't know the bottom row, okay, and of course we could, continue building this, but we're going to try and, find this algebraically with their formulas. So there's 16 boxes in the 3rd row from the bottom and 6 boxes in the 8th row from the bottom. So that would mean that if we're going to let term 1 be the bottom row, since that's how they're counting, they're counting from the bottom. So term 1 would be the bottom row. I don't know what that is in terms of how many there are, but just for my counting, then that would mean I would call term 3 16 and then 6 boxes in the 8th row. So I call term 8 6. And again, you can see then I have information to use a system. So this is kind of that way we can use a system. You could technically also use the diagram in this case, which would be okay because there's a diagram, but not every time do you have a diagram, or will you be, have quite the numbers that would be as easy to use a diagram. But I just want to talk about the diagram since it's there, is you can tell if bottom rows are, and again, this isn't the actual true bottom row, but as you move up, it decreases, but they take a box off each end, so it decreases. So the number of boxes in each row decreases by 2 as you move up the pyramid. So because of that, therefore, D would equal -2. So it decreases by 2. Now, we could use a system as well, and we'll have to use this within other questions. So I'm still going to show that. If I was to use a system, I would use my formula, which I'm going to write here. I have a little more room. How many boxes are in the bottom row? We're going to end up using this formula here anyway. So if I'm going to use this formula to find my system, I would plug in 16 when the n is 3. So 16 is equal to term 1, which I don't know, plus 3 minus 1 times the common difference. So 16 is equal to term 1 plus 2d. Or my second equation, I'm going to try and squeeze that in here, would be using 6 for term 8. So that would be 6 is equal to term 1 plus 8 minus 1 times the common difference. And so then I would have 6 is equal to term 1 plus 7d. So when I have my system now, I would have 16 equals term 1 plus 2d, and I'd have 6 is equal to term 1 plus 7d. And so when I subtract 16 minus 6, I'm going to get 10. 2 minus 7, I'm going to get -5d. Divide off the -5, and d is equal to -2. So of course, that's a lot more work than doing this. So if you're given a picture and you can figure it out based on that, then great. Or based just on the information in the question. This one we had to use the picture. If not, then remember that when you're given the two terms and what the end value is, you can use a system. So now that we know the common difference, we can find term 1, which is the bottom row. So remember the bottom row, we identified it here, but you're finding term 1. So we can use either piece of information. So let's say, for example, I'm using 16. I'm going to find term 1. When I use 16, the end value is 3. So 3 minus 1, and my common difference is -2. So that's why I had to do all this work for common difference, is to find -2. So 16 is equal to term 1 plus 2 times -2, so -4. add 4 to the other side, so 20 is equal to term 1. So that would mean that the bottom row has 20 boxes. The bottom row has 20 boxes. And we will watch the next video to, for part B and C of this example.